All right, Mr. Claxton's algebra students. Glad you found the link or the file here on my computer. Wanted to discuss with you what we're going to be doing today. By now, you should have turned in our function activity that we've been working on the past few days. You want to make sure that you've stapled that and that your name is on it, and that the graphs are somewhat in order, 1 through 12. If you didn't get 12, 11, and 10 done, or 10, 11, and 12 done, I'm not as concerned about those as I am the ones before. Taking a look here at what we have coming up with linear relations and functions, we have, the formal standards there, and then, as we kind of summarize them, you have analyzed relations and functions. That's where we've been. You've done that in the past, most likely in previous algebra classes. Now we're going to identify linear relations and functions. So we're going to focus on the function piece. We do say linear relations as well. Just relationships is what they're talking about, linear relationships. And then we're going to write linear equations in standard form. So let's go ahead and jump right into the vocabulary. Hopefully you've received your 2 packets. One is the vocabulary, which looks like this, and the other is the guided notes. The guided notes look like this. So if you haven't, go ahead and pause and make sure that everyone has both of those packets. We're going to start with the vocabulary, and we're going to skip straight to the definition for linear equation. So again, you can pause at any time if I'm going too fast. One of you can get up, grab the magic pen, and touch the center of the screen, or you can have someone pause from the computer, from the captain's chair. The linear equation. It's an equation that has no operations other than addition, subtraction, and multiplication of a variable by a constant. The key part to this is of a variable, right? What they're trying to tell you is that the variable should not be divided. And I mentioned that here in the symbolic representation. That's just the symbols. An example would be y equals 2 minus 3x over 2. That is an example of a linear equation. I could also use f of x there. But notice how x is just being multiplied by the 3, right? And I know some of you might be thinking, well, couldn't that be represented a different way? Absolutely. With that, if you understand what a common denominator is, this could be represented as y equals 2 over 2 minus 3 halves x. 3 halves of x. So notice how that x there is just right beside the fraction. That is, you're allowed to do that. This would simplify into y equals 1 minus 3 halves of x. The key there to identifying a linear equation is, variables are not allowed to appear in the denominator. The variable is not allowed to appear in the denominator. Many students will see this equation right here, y equals 3 over x, or any number over x, and they think that is linear. That is not linear, okay? Not linear, okay? Not linear. I'll go ahead and abbreviate here to try to save some time. Tabular representation, as long as you have a constant increase in x, so that's crucial. You have to have that constant increase in x. You'll see a constant increase in y. We explored this with our linear functions. That was the blue-ish function sheet, functions 1 through 3 in the previous function activity that we did. We have graphical representation. Hey, you see a straight line. The book refers to this as a verbal description as well. So like, how would you describe a straight line? Well, it's a straight line. But you might see the book refer to this as a verbal description. They're really just wanting a verbal description of a line. Moving ahead, we have a linear function. The reason why we have to, and the reason why I typed that one out for you, is because we have to distinguish between linear function and just a linear equation, because there is a linear equation that's not a function. Anything that you see of the form x equals a constant is not a function. Okay, so we do need to distinguish there. So not a function. You can see that, you know, if you read the definition, maybe take time to pause so everyone can read the definition. One of the more familiar linear functions or linear function forms is f of x equals mx plus b. You probably know it as y equals mx plus b, that slope-intercept form. Oh, how we love that. Slope-intercept form. That's slope-intercept form, okay? Standard form of linear equation. This is going to be our big focus today as far as the skill set that you need. Any equation of the form ax plus by equals c. Now, your book considers ax minus by equals c also to be standard form. So, you know, you're always allowed to add a negative to, so that shouldn't be a big deal to you. I always say, hey, if you know your ABCs, you should remember standard form, ABC. Sometimes I do denote it as C equals either AX plus BY or AX minus BY. But they're going to ask for the A value, the B value, and the C value in your skill set, in your homework tonight. The example that we give here is negative 4x plus 3y equals 10. So A would equal negative 4, B would equal 3, and then C would equal 10. So notice there how you're getting the constant by itself. Some people need to think of that whenever they're balancing equations. Oh, I got to get something by itself. Okay, well, think of getting the constant. The constant there is 10. You know, 10 is by itself, and it's in alphabetical order, right? X, Y, you know, X, Y, Z, right? A, B, C. It's as easy as 1, 2, 3. All right. Everything relates back to a song, remember? All right. So we also have 4x minus 3y equals negative 10. Now you probably noticed that I just divided each side by negative 1 here. When you divide each side by negative 1, it's really the same equation. So understand you may get some answers that might not jive or be the same as the back of the book. You need to be able to interpret those differently. So here A equals 4, B equals negative 3, and C equals negative 10. There are some teachers that only accept a positive value for B. I'm not one of those teachers. Either one of these work. You notice that just all of them are opposite. The opposite of negative 4 is 4, the opposite of 3 is negative 3, and the opposite of 10 is negative 10. So either one of those will work as an answer. Moving to our first few examples, if you want to find your guided notes packet, we're switching lanes here, so to the guided notes, separate packet, state whether each function is a linear function. Write yes or no. Explain your answer. So I'm just going to write yes or no, and then I'm going to explain the answer verbally. So what do I see here? Well, I see g of x equals 2x minus 5. I know that can be written as y equals 2x minus 5. If I write that as y equals 2x minus 5, I see that both variables are raised to the first power, and I see that the variables are not being divided, right? They're not being divided. I know that, yes, this is linear. Boy, that's a weird way to make a y. So yes, and why is that? Because both variables are raised to the first power, okay, and I can see that the variables do not appear in the denominator, Oh, speaking of which, look at example B. We can jump right to, no, this is not linear, okay, not linear, okay, not linear. And we'll discuss whether or not this is even a function when I get back, but it is not linear. Okay, not linear. Looking at C, so notice C here. Well, C, X, you do see some division, but X does not appear in the denominator. Okay, the variable itself is not in the denominator. So understand that you could rewrite this as Y equals 4 over 2 plus 7 over 2 x. So, just please, everyone, notice that, we can use that common denominator to our advantage. That might look a little more similar to you. You see that both variables raised to the first power, okay, and the variables are not being divided. So yes, that is a linear function. Looking at the next example, I'll do this, since it is a word problem, I'll do this with you when you get back. I really want to get to the standard form problems. Standard form. This is not in standard form because the constant is not by itself. So let's go ahead and let's get the constant by itself. There's a couple different ways I can do that. I can do that by subtracting 3x from each side. Subtract 3x, subtract 3x. Having a little trouble with my marker. Now, some people may write this as y minus 3x equals negative 9. Now, that's not in standard form yet. Remember that you're allowed to use what I call keep, change, change. You're allowed to keep the y and change the operation to addition and change the 3x to negative 3x. Okay? And that's equal to negative 9. The unique thing about this form, about addition, is that it's commutative. So I can automatically reorder this as negative 3x plus y equals negative 9. Okay? And you should be able to list the a value. Okay? The a value, a is equal to negative 3. What would b? Whoa, negative 3. B is equal to 1 here. Notice that there's a 1 times y is just y, and then c is negative 9. You could have also had here, you probably know this, you could have also had a equals 3, b equals, excuse me, there we go, negative 1, and c equals 9. That would also be a correct answer. Looking at B, what we have to recognize here is that there is a common factor. Okay? There is a common factor. I don't care when you take that common factor out, as long as you take that common factor out. If you don't do that, then it's not going to be in simplified form. Some people are just going to take one fraction bar, divide everything by 4. You're factoring out a 4 from each side. Basically, you're dividing by 4 on each side. So the simplified version of this is 3x equals 4y. Oh, excuse me. Getting ahead of myself. Not 4y. Equals y plus 4. I was getting ahead of myself there. Now, still not in standard form. We need to rearrange it by subtract. You could subtract y from each side if you wanted to, and you could call it 3x minus y equals 4. Okay, or you could also say that negative 3x plus y is equal to negative 4. Either one of those will work. Okay, you can list the A value, the B value, and the C value now. Go ahead and pause. And list the A value, and the B value, and the C value. Look at example C. In example C, we have 2y equals negative 1/10 x plus 5, negative 1/10 x plus 5. This is a unique problem because we have that fraction there. You know, we're going to get rid of that fraction. How are we going to get rid of that fraction? By multiplying everything in there by 10 first. That's going to make it a lot easier on us. The same equation, 20y equals negative x, 10 times negative 1/10 is negative x plus 50. Once we break it down to this, we can rearrange. You could add x to each side to get x plus 20y equals 50. And I do want you to show that x, adding x to each side. That's one way of writing it. You could also have negative x minus 20y equals negative 50 as well. So again, if you didn't show that work, add x to each side. Unfortunately, I do have to stop there for today. I am going to go ahead to your practice and show you your practice. We'll do this example, find the x-intercept and the y-intercept when I get back. Okay, so we are going to exclude or omit 35 to 40 all. We're going to omit that. This would be your practice for tonight. Thank you, everyone, for listening.